Imagine finding out that the hidden blueprint for a galaxy is exactly the same as the blueprint for basic arithmetic, like
Hmm.
discovering that the physical laws governing the entire universe and the abstract laws governing prime numbers are, well, completely identical. Welcome to this deep dive into Daniel Toupin's 2026 treatise on the nature of nature. Our mission today is to explore how a single mathematical structure connects the distribution of prime numbers to quantum gravity. Okay, let's unpack
Yes,
it.
it really is a staggering claim. I mean, we are looking at a framework that suggests these aren't just similar patterns in nature, right? They're the exact same mathematical object, just viewed from different angles.
Right. And to wrap our heads around this, we have to start with a concept called the Haar measure. This was introduced back in 1733. Think of a university calculus problem where you have to find the surface area of a sphere. You need a method to measure it so that no matter how you spin or rotate that sphere in space, the area you calculate stays exactly the same. So the Hare measure is basically that perfectly fair universal ruler. It measures volume while flawlessly respecting a system's underlying symmetry.
Exactly. And what's fascinating here is a specific property of this measure called self-duality.
Self-duality.
Right. So instead of getting bogged down in the heavy math, think about a standard 3D coordinate graph. Self-duality means the math treats a flat 2D plane and its exact perpendicular opposite, like the 1D line, shooting straight up from it perfectly equally.
Oh, wow. Okay.
Yeah, it creates this inescapable mathematical balance.
Hold on. So it forces a balance, but math equations don't dictate how a baseball flies or how an electron moves, right? Or do they? How does this abstract geometry actually enforce the physical realities we see?
Well, that is the core of Toupin's treatise. Because of this self-duality, an identical mathematical reflection appears across three seemingly completely unrelated fields.
Okay, here's where it gets really interesting. Let's use an analogy for you guys listening. Imagine taking a massive, incredibly complex map of the universe and folding it perfectly in half. Points that seemed completely unconnected, like prime numbers on one edge and quantum gravity on the other, suddenly touch and perfectly align.
That is a great way to visualize it. On the physics side, if you look at celestial holography, which maps quantum gravity, you see a reflection called shadow symmetry.
Right.
It's an operation where a mathematical property, called a conformal dimension, swaps with its exact opposite. Then, in standard particle physics, we see CPT symmetry.
Which is the swapping matter and antimatter thing.
Exactly, yes.
Yeah.
That's the exact balance you get when you swap matter with antimatter in reverse time.
Wait. That's physics. But Toupin points out that this exact same folding of the map happens in pure math, right? With the Riemann Zeta functional equation.
Yes. The Riemann equation dictates the behavior of prime numbers, and it has an identical reflection where a variable swaps with its exact opposite. The fixed point of that reflection, the exact crease in your folded map where everything perfectly balances, is at precisely 1/2.
I'm trying to process this. You're saying that the critical line of the Riemann hypothesis, which is arguably the biggest unsolved problem in pure math, shares the exact same mathematical boundary line that keeps quantum gravity stable.
I know it sounds crazy, but
Yeah.
yes, it's possible because they are governed by the same underlying geometry. Which brings us to how this actually shapes the reality you experience.
Right. And it's wild to think about because we're taught that the quantum world is totally random. You can't know exactly where an electron is, just the probability of finding it. We've basically been using something called the Born rule since 1926 as a highly educated guess to figure out those probabilities.
Yeah, the Born rule tells us to square the wave function to get the probability. It works beautifully, but for a century, physicists couldn't prove why it works. Toupin's work finally shows it isn't a guess at all. It's a rigorous theorem.
That is massive.
It is. If we connect this to the bigger picture, the Born rule is the only probability curve mathematically possible that respects both that universal fair hair measure and gauge invariance.
Let's clarify gauge invariance for a second. That's essentially the universe's rule that physical laws must work exactly the same way, regardless of the vantage point you measure them from.
Right. You nailed it. Physics isn't inventing these rules. The underlying geometry of this mathematical space is forcing them into existence. There is literally no other way for the universe to calculate probability without breaking its own fundamental symmetry.
So what does this all mean? It is a massive paradigm shift. It means space-time isn't this fundamental absolute grid that the universe is built on top of.
Right.
It's actually a secondary structure built from intersecting light rays that are parametrized by this deeper self-dual geometry.
It perfectly connects the smallest, most unpredictable quantum probabilities to the vastness of quantum gravity. And it does all of that using the exact same geometric ruler that organizes the prime numbers.
Which leaves you with a pretty wild thought to mull over. If abstract prime numbers and the fundamental structure of our physical universe are just different reflections folding across the exact same geometric space, well, are you living in a physical reality or a purely mathematical one?